Welcome back, parents. We are going to be moving on to a new topic scale here in math. We are going to be moving on to multiplication. So this might be something new to you, and some of you might have seen it before, but this year we're doing SRG grading, and so the students are working at a level 1, 2, 3, or 4. And our goal is for the students to be at a level 3 ultimately, and that might be at the end of a unit or the end of a chapter in math. So we usually start out at, or we do start out at the 2 and then work our way progressively higher, and every student's at a different level. So this is really a way for them to show what they know in math and reading and writing. We have these for all of our subject areas. So anyway, we're going to start right now on our new topic, which is multiplying by 1-digit and 2-digit numbers. And I also want to add that we're doing 3- and 4-digit numbers. That's another scale, but we're kind of incorporating it into this scale right now. And our goal is for the students in shortened version here to be able to do a multiplication problem and explain to us why or how they solved the problem. But we're going to start at our 2, where we're basically just multiplying a whole number by up to a 1, 2, or 3-digit number. So we started out with just 1-digit by 2-digit and then worked our way up. But I wanted to show you, we started out by reviewing our multiplying by tens, hundreds, and thousands. And this is going to be really helpful when we do our new way of multiplication, because there's lots of zeros when we expand our numbers out. So we taught the kids to focus on the easy fact of 3 times 4, which is 12. But 3 times 40, well, that's not a quick fact for anyone. We know that 3 times 4 is 12, and then we can just add that 0 on. Same thing with 3 times 400. We did our easy fact of 3 times 4 and then added our zeros. And then 3 times 4,000 is 12,000. So if we're looking here, and this is one thing that sometimes the students struggle with a little bit, is that 5 times 4 is 20. So when we go down here, 5 times 40, a lot of times the kids will say 20 again. But we want to make sure that we're adding that 0 on there. So it's 200. And then 4 times 400 is going to be, we do our 20, our easy fact, and then we'll add our 2 more zeros. 1, 2, 3, 4 times 4,000 is 20,000. Oftentimes the kids will drop a 0 because of the 20. They'll think, oh, I already have 1 0, but they really need to add 2 more. So the zeros can be a little bit trickier for the kids when they're solving that. But if they know those easy facts, it's going to help them when we move on to our multiplication. And so we're teaching the students a couple different strategies for solving multiplication problems. The way we learned is with the standard algorithm, where we had maybe 14 times 3 and we multiplied this number by this number and got our answer. But this didn't really help us understand what we were doing and why we were doing, and so now we're doing it so the students are able to really understand how this process works and why they're doing it the way they're doing it. So our problem is 6 times 13 here. So we're going to actually break up the 13 into easier numbers to multiply, and I just did expanded form that we talked about in our place value video. 10 plus 3 is going to get you 13. So we put the 10 here and the 3 here because we know that that equals 13, and we're multiplying it by 6. So here we essentially have 6 times 10. So if we counted, there'd be 60 squares in this box. And then here we did 3 times 18, or excuse me, 6 times 3, which is 18. And then we just add up those two numbers to get our sum of 78, which is our product of our multiplication problem. So 6 times 13 is going to be 78. So if we counted that, we would have 78 squares. This may seem confusing and a lot, but once the kids get to doing it and practicing it, it becomes really natural to them. And they're able to just visually understand what we're doing. So I'm going to move over here, and we're still working at a level 2. We're just solving the problems and we're showing our work. We're not yet to our explaining, but we have to get a good foundation of this. So I'm going to move to a 3-digit by 1-digit number here. And so I essentially am going to do a different way than the area model over here. So I'm going to take 4 times each one of these digits. So my first one is 4 times what would be 100, because the value of the 1 is 100. Here, my next one would be 4 times 90, because that's the value of the 9. And then I can do 4 times 5. So we still have a little work here, but when I multiply this out, 4 times 1 is our easy fact, which is 4, add 2 zeros. 4 times 9, 90, but let's do our easy fact of 4 times 9, which is 36, and then I'll add my 0. And then 4 times 5, which is 20. And it's really important that when that we line up the digits when we're doing this, because if the students do 400 and then they write 360 and 20, we're not going to get the same answer as if the numbers aren't lined up correctly. So here we have 0, 8, and 7. So our answer is 780. So if we wanted to solve that using our area model or what we did over here, we would break this down into 100 plus 90 plus 5, multiply that by 4. And then we could again do our problem 100 times 4, 90 times 4, and then 4 times 5. And then we can solve that to get our 780. So these are all of our level 2 skills. And we're going to be moving next week to really talking about explaining their strategy or explain how they solve the problem. So here's some sentence starters that they might say. I solved my problem by, or the first thing I did was, I can prove my thinking by, the strategy I used was, I know this because I learned, I know. Those are all ways that your child can start to explain how they solved this, and then they'll be at the level 3. If the targets are confusing and the topic scales, we're going to have an SRG parent night on Thursday, October 13th at 5:30. So if you would like to come and learn more about how we're grading this year and how the students are learning and we're breaking up their learning, come join us then. So hopefully this will be a good introduction to multiplication, and I'll keep adding some more as we keep going.